Hello, so answering question number 6, the presbyopia disorder, or it's not really a disorder. It's something that happens with aging. When the eye starts aging, the muscles they get harder. So basically, what happens here? Okay, so we have the iris, and the muscles in the iris are responsible for constricting or dilating the muscles based on the light and based on the distance between the objects that we're seeing. So they kind of like make it suitable for the light to hit the retina. So what happens here is that the iris or the muscles, they're really hard, they're stiffened, and they're not able to constrict or dilute as usual as they're supposed to. And again, this happens with aging. So what's going to happen here is that they're going to stay as they are, and then the light is just going to, and then it's going to pass through it, and it's going to hit behind the retina, a little bit behind the retina. Why? Because again, it didn't the muscles in the iris, it didn't really make it suitable enough for it to hit the retina itself. So it's going to hit a little bit farther behind the retina, and that's what causes the blurry in the image, or not being able to see that well. Now, um, a great example is the cortex and the concave lenses. That's how it is. That's what it's for. It's for far objects or for close objects. It differentiates. Okay, so the process of how we see is that the light is going to hit the rod cells. And the rod cells are gonna, and then the rod spin converts to metarubsin 2, and then the metarubsin 2, it's gonna initiate, or it's gonna activate the transduction. Transduction it activates phosphodiesterase and hydrolase cGMP, and then cyclic GMP is scarce, and it closes the sodium channel. It closes all the sodium channels, and that's how the membrane gets hyperpolarized, and the electrical impulse then is being sent to the brain, and we can see that image. That's how it is. Thank you.